Hide me now under your wings. Cover me within your mighty hands. When the oceans rise and thunders roar, I will soar with you above the storm. Father, you are king over the flood. I will be still and know you are God. For my soul in Christ alone. Know His love in quietness and trust. When the oceans rise and thunders roar, I will soar with you above the storm. Father, you are king over the flood, and I will be still and know you are God. I will be still and know you are God. I will be still and know you are God.
We are one in mission and vision, instilling excellence in electrical profession, having a dynamic professional association, making innovative contribution to our nation. Rising to any challenge, involving what's homes and boats, B-E-R-E-E and R-M-E, connecting industries by the electric circuits. Bind us together, bind us forever, with power cords cannot be broken. Bind synchronize our hearts to reach greater heights and brighter lights. We serve humanity with the power of electricity, making rigid transmission, great for reliability, ensuring little power loss and high efficiency. From shifting from one place, the use of all energy. Bind us together, I believe. Bind us forever, I believe. With our hearts cannot be broken. Bind us together, I believe. Bind us together, I believe. Bind us forever, I believe. Synchronize our hearts to reach greater heights and brighter lights. There's only one institute, no one else can substitute. There's only one IRE.
A pleasant morning to everyone. Welcome to the TCPDC Independence Day webinar series, guided by this year's theme, Transcending the Challenges in the New Normal by Embracing Resiliency and Complementarity, comes at an auspicious time as we boldly move to digitally transform and reshape our organization in the new normal. I am Yasmin and I will be your host for today's activity. Now, to formally begin with our program, may I call on the IIEE Vice President for Technical Affairs and the Overseer for the Training and Continuing Professional Development Committee, Engineer Feliciano F. Padua III, for the opening remarks.
Hello, Yas. Naririnig na ako.
Yes, sir.
Okay. Good morning, everyone. Maligayang araw ng kalayaan. So, Happy Independence Day para sa inyong lahat. Again, thank you to all of you for attending this pre-webinar by our TCPDC, Effective Grounding on 440 Volts, Fire Pump Code and Intent, IEC, and any provisions of banding and grounding. I hope that marami kayong matututunan dito kasi magagaling yung ating mga speakers at magamit ninyo sa trabaho at sa mga ibang activities. Thank you sa mga walang sawang mga ating speakers, Engineer Charles Singson, Engineer Jesse Santos, and Engineer Condrado Binondo for sharing your knowledge and time, lalong-lalo na ngayon, holiday. So maraming salamat. Just an update sa ating lahat. Small update. Remind ko lang na paki-update ating membership portal. Pasyalan po natin yung membership portal kasi working progress na yung mga CPT points ay makikita na ninyo sa inyong portal. Just pag nakapasok po kayo, just click the CPT points. Nandun na yung program, webinar na natinan ninyo. Anong araw, anong oras, venue, at ilang CPT points. Sa right side po nito, nandun na din yung mga e-certificate. Pwede nyo kung i-click ito at makikita ninyo ang inyong e-certificate. So, you can now download, print it in your house or offices po. So, hopefully, malilink na natin ito within the year, yung portal natin sa PRC para doon na nila tignan ng mga CPT bonds kung mag-renew kayo ng mga license nyo. Yung COGS, pwede na i-request online. Pero yung process po, dadaan pa rin sa normal process na ang inyong chapter president ang magre-release ng inyong COGS. Okay, just again an info, yung first issue po ng EE Magazine ay na-upload na po sa ating website. More on reliability ng ating renewable energy. So I would like also to take this opportunity. Kasabay po nito, habol po kayo sa Western Mindanao Regional Conference. Ongoing po, June 11 hanggang bukas. So, mayroon po tayong ongoing conference, and then sa June 25 and 26, ito naman po yung Central Luzon Regional Conference. So, would like to thank the support, yung mga regional na palaging sumusuporta dito sa ating training, si Foreign Region, Regional Governor Orlando Villapana, at saka itong masipag na kaibigan natin ng Metro Manila Regional Governor, si Alvin Wagan. And of course, itong ating TCPDC na palaging nag-iisip kung anong mga webinar na ibibigay sa inyo. Headed by Igor Biodax. At ang mga members na nandito, sila Jonathan, si Gobong, si Sir Max, and si Sir Julius Talakop. Maraming salamat sa inyo. At saka itong mga staff natin, sila sila Yela. Maraming salamat, sila Micah. Maraming salamat sa inyo. And with that, again, thank you everyone, and have electrically safe and healthy ahead of us. Thank you po.
Thank you very much for your warm opening message, Sir Jojo, and for the announcements, for the information of our members. And we would also like to acknowledge the presence of Sir Alexander Ko. He is our So, one, if you have any question related to the topic, kindly utilize the Q&A box for easier monitoring, and this can be found at the bottom part of your screen. You can find it in the lower part. So you may also raise your hand if you want to ask live, since we will have a Q&A with the last three speakers at the afternoon at the end of the presentation. And the presentations will be sent to your registered email address, so you don't have to leave your email addresses at the chat box. So you don't need to leave your email address to the chat box, since we already have your email address. And for the certificates, this will be uploaded to your IIEE portal. So kindly make sure to visit and update your portal so you can have access to your e-certificates. And we would also like to request that since we are still adjusting to the new portal, kindly wait at least 10 working days before your certificates will be uploaded. So that's all. So now, without further ado, to formally introduce our first resource speaker, may we call on one of the members of the TCPDC, Engineer Max Adarlo.
Good morning. Our technical speaker for today have 8 years of his career was spent in the US, where we have worked on commercial, institutional, industrial, and multi-family mixed-use residential. He has a robust understanding in the lighting control in compliance to ASHRAE 90.1 and California Energy Code, known as Title 24, especially for office building projects. Through his career, he has been part of the LEED project in the Philippines and the NFPA code compliant. He has experience as well in solar and fire alarm projects in compliance to Californian State Fire Marshal Guidelines and NFPA 72. Currently, the President and CEO of JC Santos Corporation. Let us welcome Engineer Jesus Jesse N. Santos Jr.
Good morning, everybody. Good morning, Sir Max. Mm,
Good
just
morning,
let
Sir Jesse.
Good morning po, Sir Feliciano. Sa wakas nakita rin tayo. Binabati ka pala ng
Salamat.
tatay ko. Binabati ka pala ng tatay ko.
Ganun ba?
Yan mo
sir,
sasabihin ko
salamat
pag
sa'yo.
nag-usap pag dumalaw ako sa kanya kung saan siya nakahiga ngayon, babanggitin kita. Anyway, sige, alam ko sa happy, pa? Sige, okay. So, if there's something that is not clear, the audio is not clear, just let the host know that you are not receiving any good audio so that I could, don't worry, don't hesitate to butt in if there's something that is not clear in your audio. So once again, good morning to everybody. It's 9:17 here on the dot. So I just came home like last year. Then when I went home, sabi ko sa misis ko when we were in the United States spending 10 years, I think it's time to go home siguro. Parang I want to naman to share what I have learned. It's a continuous learning. Tinabi nga ng dad ko nung after ko matapos mag-aral, sabi ko sa dad ko, sabi niya, Papa, sabi ko, I call him Papa. Pa, tapos na ako mag-aral eh. So okay na ako, I mean, I could already work. Tapos sinagot niya ako, sabi niya, my son, okay, learning is never ending. Even ako kahit matanda na, I'm still learning. So kaya ina-advocate na mga IIEE, it doesn't mean that you know already something, you will stop learning. No, so we will only stop learning when we die. Okay. So pagbalik ko rito, when I try to find, I want to reactivate my IIEE. So I got the chance to get hold of Engineer Leo de la Cruz, then up to the point na fortunately we got one project from SM, and then during coordination meeting, and then I heard the name of Engineer Charles Singson. So I grabbed that opportunity to talk, try to a little bit try to approach because hindi nila ako kilala. But I was surprised that from my experience on my bagong kilala, hindi pa solong kakilala ko si Sir Charles. He was so approachable pala, talagang nakangiti. So we sat down and then we asked question, what is your intent? So sabi ko, my intent is I just want to share. So sige, sama ka sa akin. Tayo. Pasok din kita sa speaker, as a speaker, whatever expertise you have. So Sir Charles, alam ko nandiyan ka on the background. Maraming salamat. Hindi ako makapagsalita dito. Not because of you kaya ako makapagsalita. So magandang umaga, and then so nakita ko kasi I hope we have learned something about COVID. Okay? So, andun yung buong mundo na not only the Philippines, na there are things that we are unprepared. So, which in line with my career, may pumasok sa isip ko, ito isang topic, this is one topic that I observe that's being taken for granted. Na isa to sa pinaka-importante in terms of safety. Kaya nga if you would notice, in Philippine Electrical Code, in National Electrical Code, meron siyang sariling article. Compare with other electrical equipment load. If you try to notice. So it means, I would now start para hindi na tayo magtatagal. Okay, I will now share my slide to begin. Let me know. So that's why I started to create slide. Okay, and then just bear with me. Okay, so the topic would be for me fire pump. Okay, but now I just a little bit. Last night I just tweak a little bit my title. It's to focus on the PEC Article 6.95. Dito tayo magko-concentrate. So, let me try to things. Okay. So siguro let's start muna, no. What is a fire pump? Siguro in my experience in my career, no, if I have a discussion, meeting, sometimes we have to be cautious with our terminology. Sometimes may nagsasabi wire, may nagsasabi cable, may nagsasabi conductor. So I'm advocating when we have a formal speaking, discussion, of course, okay lang kung nandyan tayo sa kwentuhan on the side. But if we're going to have a chit-chat or discussion between, lalo na between engineers, we go down to the wire, to the format or the official terminology. So, minsan pag wire, and then what I do, minsan pag hindi kami magkaintindihan, I go always down to the wire. Let's define it. Okay. So siguro what is a fire pump? So a fire pump is as defined. So ang nakita ko lang, okay, one of the book codes, standards, rules or whatever, the only word fire pump that I got a definition is from National Fire Protection Association. Which a fire pump is isa siyang device that provide required water flow and blah blah blah. And then it includes the accessories such as yung mga tinatawag natin na jockey pump. So that the fire pump is a package. Okay. Normally, though there may be some rare cases, there's a fire pump that without jockey pump. But in most cases, it is a package. But the fire pump itself is the job of fire protection engineer. So tayo, we are electrical engineers. We will talk about ito. What are the objectives of this lecture? So we will not be covering the mismo fire pump. We will try to learn the basics of designing electrical power system to feed the fire pump system. So we are electrical. Okay, we are not mechanical. Our expertise is electrical. So we don't have the luxury time. It will take days, okay, ilang days to cover every detail. So what I was thinking in my limited time of speak is just to understand the basic principle behind the fire pump electrical power system. So what topics to be covered? So expect to discuss about the applicable standards, yung mga power sources, and then there's a topic about the continuity of power. Remember, fire pump to is not an ordinary load. And then if ever we're going to use a transformer because the service voltage is different from the utilization voltage, and then paano mo siya i-wire, paano mo siya i-route, something like that, and then some essential items. So what is not covered? Okay, yung system performance niya, the fire pump controllers and how to maintain it, and during the testing commission if it's accepted, and then yung mga routine tests, yung mga jockey pump, and then of course we will not talk about fire alarm system. So we will not cover this one. So let's start off with what codes and standard books shall I read? Okay. I mean, shall maybe not should. So pag should kasi, para ginamit ko na yung strong word na shall. So when you say shall, it is a requirement. When you say should, it is a recommendation. So para mo sinabing sa Tagalog, when you say should, dapat. Pero pag shall, kailangan mong gawin. May mababasa ka naman sa code na shall be permitted. Shall be permitted is pinapayagan, but it is not a requirement. So for here, a mandatory na tayo. Okay, this is a required or a mandatory. It is our PEC. And then there are some supplementary because as we all know, Philippine Electrical Code has been modeled to National Electrical Code. And if you dig into National Electrical Code, is in-extract pa nila para pagandahin palalo to come up into a standard of installation for fire pump is NFPA 20. And then, paano mo siya ipa-power up in terms of the emergency source? If you're using a generator, you might want to read the NFPA 110. Okay? So emergency and standby power system. Sometimes you have to be very careful. It doesn't mean that you have a genset. It is considered as emergency power. It might call only for standby power. So we don't have the time to discuss about. I just want to open your eyes, okay? So dito sanay tayo. Meron akong emergency generator. Minsan they call it always emergency. Kasi from the word emergency, that is critical. Okay? You could say, baka naman what you mean is standby power. So any mention in fire code of the Philippines about fire pump, the only section that I have read that was mentioned is on 10.2.20.2. Sinabi lang doon, in Fire Command Center, kailangan may status indicator for fire pump. That's it. Okay. So, of course, kung walang Fire Command Center, I mean, by logic, you don't need. So, but it doesn't mean na wag mo lagyan. Maganda rin kung lagyan mo. Regardless if there's a fire command center or not. Of course, there's a requirement when you need naman a fire command center, usually for 10 floors. I have to double check on that, mostly for high rise. So, what is the intent? Okay? So, mga kasama or listeners, okay? In everything that we do, di ba? Bakit ka ba ng electrical engineering? Of course, in everything that we do, that the outermost is what to do. Okay, the second degree is how to do it, and then the most na kailangan natin maintindihan in everything that we do is not only about fire pump, is why do you do it? Ano ba reason ba't mo ba ginagawa? What is your objective? What is your purpose? What is your intent in doing a certain task or a certain goal? Wala lang, mahirap naman yung gula. Gusto ko lang pumunta ng Baguio. Bakit? Wala. Gusto ko lang. Walang reason. So, in my life, it's nice to have a big purpose. So, our intent in fire pump is kailangan maging reliable. Number one, maging reliable siya. Okay? And then, dito, should the fire pump be called upon function, it is considered as sacrificial. Kailangan mo siyang i-sacrifice. Bakit? Okay? Why do you want? Parang ganun. Usually, kailangan mo ang i-save, wag masunog ang motor eh. So, let's go on to the next slide is, so to answer that question, I make a boundary. On the left, the general philosophy for electrical is maprotektahan yung motor, yung pump, di ba? In terms of siguro an overcurrent protection device, before masunog ang motor because there's a ground fault, whatever abnormal condition, mag-off na, mag-open or mag-trip na para ma-save niya yung motor, ma-de-energize. Siyempre, sa electrical, I know you would agree with me, everybody would agree with me, that top priority is safety. Dun, siguro on the next level, andun na yung reliability, costing niya, yung investment niya. Pero pag if you're going to visit my website, of course, I put a level of my philosophy. There would come to a time na magbabangga, hindi magko-contradict yung safety versus cost. Kasi higher the safety, usually higher cost. Okay? So, of course, it doesn't have to be kailangan laging above minimum. There are times na wala eh. Di ba? The building is only public elementary school. You don't want to use na matitindi talaga mga equipment. Wala, budgeted lang to. But there are type of building that you need talaga as robust na safety. For example, hospital, data center, any critical facilities. And then, of course, number 3, of course, protect the electrical rated equipment and conductors from producing high temperature that may constitute a fire hazard. Kasi, ang kalaban natin is yung heat di ba? We don't want to discuss, alam na natin siguro lahat yun. So, now on the right side, pagdating sa fire pump, you will turn 180 degrees. Kaiba naman ang philosophy. Dito lang yung, sa buong electrical code, dito lang yung naiiba siya. Why? Because the requirements of focus, ang point dito is, kailangan hindi mawalan ng power. Kailangan hindi mag-trip ang breaker. Bakit naman ganun? Of course, fire pump will do his job pag may sunog na. We are not talking already na wala na. Kasi pag umandar ang fire pump, it's time to leave out the building. We are not talking of yung gantong nakaupo tayo ngayon, wala na. We're talking if you need to leave your house now. So, ang electrical safety is considered a secondary objective for the fire pump. I'm not saying na hindi mo secondary na lang talaga siya. As such, equipment and conductors may constitute a fire hazard. Pwedeng umabot to that point. Wala ka nang masyadong iniisip kung maaari na, okay, paano ba maproprotektahan yung conductor ko? Wala na, kailangan talaga. What we mean on the next slide is, okay, just capture this motto. If you would accept my motto, no matter what kasi, the pump must run. Just keep that baby going and pumping water until it dies, hanggang masunog na siya. So, para sa ating electrical, we don't want to be blamed. Sasabihin ng mga fire protection engineer or na contractor and the owners, kasi kaya hindi umaandar yung fire pump ko kasi hindi naman nabigyan ng power, nag-trip na yung breaker o kung ano-ano man ang mga other reason because of electrical. Lagi nga tayong sinisisi pag may sunog sa Pag may sunog sa balita, lagi because of electrical. So here, okay, just keep it going. Paandarin mo lang dapat umandar siya. Ibig sabihin, masunog, ang point natin dito mga electrical engineers is maunang masunog ng fire pump kesa tayo. Kahit masunog ka fire pump, but we are still available to give you power. If you remember the New York, the Twin Tower attack during that 2011, that we call it the 911. Don't you know that yung isang tower doon na nalagla, yung bumigay na, alam nyo ba, 2 weeks yung fire pump tumatakbo pa, bumabaha na sa basement. Umandar yung fire pump nasunog yung building, tapos di ba nalaglag na yung building, nag-crash na yung building, di bumagsak na yung building. Ano yung bumagsak ng building na nasa basement yung fire pump? Don't you know mga kasama, 2 weeks tumatakbo pa yung fire pump doon. So, that is how should be a fire pump to be dependable and reliable. Kaya nga pag I have a client, if we sit down before we do the design, siguro it's not about code. Okay yun, that's I'm advocating code to read it. But tinatanong ko lagi sa owner, my last question always to the owner is, pag nasunog ang building mo, pag nasusunog ang building mo, of course, we don't want to imagine umabot sa ganun. Pero kung mangyari yun, ano gusto mong matira sa building mo? That is the most important. Ano ba gusto mong matira sa building mo? Pag meron kang something na may answer siya na meron siyang gustong isave, mas mataas yung level ng safety mo. Ang downside, of course, mas mataas ang cost. Pag sinabi na wala, okay lang. Pag nasunog, total, wala naman importante dyan. So, you just go, maybe you just go up sa minimum requirements ng code. So, the article in PEC is Article 6.95. Okay? Ang 6.95, okay, ina-amend na niya. Sinusupersede na niya. Kasi chapter 1 is about clearance, so chapter 2 is about wiring, protection, chapter 3 nandiyan yung mga size ng wire, paano yung wiring, and then chapter 4 is about yung mga appliance, mga pumps, mga motor, air conditioning. May mga rules dun di ba? Most likely from 1 to 4, pinoprotektahan mo yung safety, pinoprotektahan mo yung mga equipment, yung tao, yung tao, kailangan may clearance ka, yung wire mo. Pagdating sa 6.95, ino-override na niya yun. Okay? So, if you're going to read or you will continue reading 6.95 para hindi kayo ma-confuse. Okay? So, pag fire pump, pag hindi fire pump, follow 1 to 4. Okay? When you're going to make a design or install a building. Okay? So, yan, importante kasi ina-amen niya yung 2.40, yung service, yung 4.30 as about the motor. However, is that modified by Article 7.0, the emergency system. So, yung may article na 7.0, susundin mo pa rin yun. Ito lang yung article na you would follow both. Kung merong sinabi sa 6.95 that ganito ang wiring pag emergency source of power, and then may binabanggit kasi sa Article 7.0 kung paano mo siya i-wiring if you're using already the emergency power source. What characteristics needs to be considered of a power source? Okay. So anong may consider mo sa power source? Number 1, first, kailangan maging reliable siya. Okay. A source of power required at least one reliable source. May mga, okay, how should I say? Let's go to the next slide. May mga, it's a battle, There are some, kahit nga may mga electrical designers who are trying to discuss with me, okay, trying to argue with me. Wala naman reliable source Okay. The chances are, my answer is yes. Though, because of, why? Because of our personal opinion. Why ko sinabi yun? Because there is no definition in the code in the world what is a reliable source. Though we have our own judgment. Kasi in our practice, We are exact science and number. So pag sinabing, inutusan mo yung anak mo, anak, bili ka nga ng maraming asukal. Mahirap yun eh. Pero pag sinabi mo, bumili ka nga ng 2 kilong asukal, that is definite. So there is no really a definition that you can find a reliable source. Though we have now our own intuition naman. So nagbigay din ng idea yung mga NFPA siguro pag walang yung kung utility ang ginagamit mo. Kunyari, itong utility ang ginagamit mo. Okay? So sample of utility and cooperative. May Binaralco, may Paleco. So these are the samples of utilities and cooperative. If they have a record that it's just a sample, okay, on how to judge if the source of power, if utility is reliable. It may, okay, it may be pag talagang wala siyang blackout or brownout for hours in a year, so may mahirap i-attain, pero most likely, hindi maging reliable. Unless, sabihin mo sa cooperative, pag sinabi ng cooperative, reliable kami. Kung in my advice, o di papirmay mo siya, sumulat ka na reliable yan. Otherwise, pero most likely hindi ka gawin ng mga cooperative yun. So, ngayon, paano? If ever na it's not reliable, so you need at least 2. Kasi if it's reliable, you do not need a backup power. Okay. But if it is not reliable, you need another backup. Okay. We'll just discuss what are those backup power. So, 1 lang yan, okay? Doesn't mean na ang fire pump mo is laging ang source of power mo is utility lang. Okay. Another source of power, you could have an on-site power production. Okay. So, ang pinakasikat is siyempre, ang diesel engine-driven fire pump. So pag ganyan, you do not need a genset anymore for backup. So, pina-permit ng code na pag diesel engine-driven fire pump ka, okay ka na. You're already complying the code. There are things needs to consider. Of course, pag nilagay mo yung diesel engine-driven fire pump, siyempre, you have to consider the ventilation kasi parang in the concept, parang sinaksak mo dun yung generator sa mismong fire pump. Then the fuel supply, the combustion air, and so parang sa engine. And then there's a high maintenance, of course. Higher maintenance ang diesel engine kaysa electric driven fire pump. So, where alternate source of power shall not be required. Okay, ito yung mga, as what I have mentioned, yung engine-driven, pag sa Amerika meron siyang steam turbine, and then electric motor-driven fire pump. So ito yung mga shall not be required. Okay. So, itong on-site power production facility, don't get it wrong, okay? This is not an ordinary standby generator, but rather a facility that produces its own power on a continuous basis. So, you might asking question later so ano kailangan, paano gawin to. So, I'm not discussing how to design. Now, it's now your job. Iba-iba tayong designer. May kanya-kanyang practice. May iba-ibang standard din, yung style niya, strategy niya. So, para mo sinabing ganito, if we're all both going to Tagaytay, kasi importante, ma-attain mo yung makapunta ka ng Tagaytay. Yung mga codes and standard, para mo siya sinabing traffic rules. Pag nagmotor ka o marami kang style, pumunta kang Tagaytay, pwede ka mag-public commute. Okay, may dala kang sasakyan, nagda-drive ka. But while you're driving, pwede yung isang kasama mo, iba yung dadaanan niya sa SLEX, yung isa sa Cavite. Regardless, when you're driving, parang ang PEC, yung traffic signs mga. So yun ang pinakamagandang, I could say, parallelism in terms of the code. So pag may makikita kang maximum na 80 kilometers, o kaya may no left turn, o kaya pine-permit siya itong araw na to, diretso, pine-permit ka yung lane na to, diretso ka, itong lane na to, naka-araw papunta sa kaliwa, you are permitted. Kasi mag-iba yung required and permitted. You are permitted to turn left on this lane and so forth. Okay? So, located and protected to minimize the risk of damage by fire. So, kaya nga, mga listener, meron pa nga mga local jurisdiction. For instance, in Los Angeles City, meron ang mga AHJ doon. Sometimes we call here as building official. They do not permit your diesel engine-driven fire pump na nasa loob ng building. Kailangan nasa labas. Which in a way, there's a sense on that. Medyo sensible. Kasi nandun nga yung sunog sa building, but nandun yung fire pump mo. So, minsan, I do not argue na. I don't argue. Kasi it makes sense eh. Kung may lote pa, no? Kasi nga, however, here in the Philippines, talagang kumari, kakainin ng real estate yan eh. In every property. Magkano sa, I have asked last year in somewhere in Cubao, 120 ata, 120 pesos per square meter ang value ng bandang Cubao. So kung lalagay mo pa tong fire pump dito sa labas, kakain ng lote mo, kaya pinapasok. Okay? But kung ako tatanong, given a chance, kung may pera yung owner, siyempre maganda ilabas mo. What is the sense? Kasi nandun nga yung sunog sa building, nandun yung fire pump mo. So what if not reliable? Okay, if not reliable, kailangan mo at least dalawa. You could play with this, okay? Doesn't mean na ang backup mo is generator, pero pwede rin naman solar and so forth. Wala naman sinabi na, wala naman kasi sinabi sa code na as backup power mo is genset only, and then, okay, solar power for backup is not permitted. Okay. So, if sourced from utility, what code section is telling that the power supply conductors for the fire pump shall be tapped from the service conductor? Kasi ganito yung dapat mong gawin. Okay. So, to the next slide, we will discuss a little bit detail, but not too much that detail. Itatap mo siya ahead ng service disconnect. Or, sabi na sa configuration number 2, you could do a separate fire pump service. So, pwede yung 2 metro from the utility. Okay. So this is the section, okay? Sinabi niya kasi, connection located ahead. Ito yung section. I don't want to put many words sometimes kasi nga, naduduling ang mga nagbabasa. So for this, pagbigyan niyo lang ako, okay, in-snip it ko talaga yung code section. Sabi niya, and then I highlight in red, if you're going to have a closer look na kasama, sabi niya, connection located ahead. So hindi lang ahead. Okay, hindi natatapos yung location ahead. Kung sabihin yung service disconnect mo, hindi lang sinabi niya ahead. Isa na yon, but nakalagay in. Okay? Not with the same cabinet. So halimbawa, kung meron kang if you disconnect, your service disconnect, for an example, is a breaker, hindi pa pwede doon lang sa line side na terminal ng breaker. Sabi niya, kailangan wala doon sa cabinet ng service disconnect mo, o kung switch gear man yun, or whatever is your disconnect. It may be a switchboard, pwedeng sa bahay, panel board. So, of course, ibang usapan, if medyo nalito kayo, siyempre we have to go down to the wire. What is a service disconnect? So, before you try to discuss with me further, and then kailangan alam mo ano ang service disconnect. Kasi after the service disconnect, you are not permitted. So ito yung isang sample na setup na effective sa experience ko. Okay. So magkaroon siya ng sariling service. Okay. Isolated or different from the service na ginagamit mo to power up your building. However, ang dami ko nang discuss. There are utilities, cooperative, na sasabihin nila, hindi pa pwede to. Hindi ba pwede pang-kilometro? Something like that. O hindi ba pwedeng gawin yan? So, in my experience, okay, nung nagpunta ako my father did not want me to go there because sa US, pero finally napapayag ko siya. For the first 3 months, kasi wala akong trabaho. Okay. And then, nag-uusap kami ng father ko, gawin mo, anak, magbasa ka ng NEC lang. Araw-araw. Ngayon ko siya na-appreciate. Bakit? Kahit na sinong makipag-usap sa'yo, bawal yan kahit na sinong authority, building official, authority having jurisdiction, kung sino man. In everything, pag sinabing hindi pa pwede, ang lagi ko lang sinasabi, show me the section in the code. Pag sinabing hindi na kailangan yan, doesn't mean. O sige, sinasabi ko sa discussion ko. So in PEC, let's throw out of the window. Hindi pala kailangan. Or you could say to IIEE that hindi na kailangan to. Otherwise, you come back to me if kumidala kang code section. Otherwise, para tayo nagbo-boxing, ako nasa loob ng ring, ikaw nasa labas, hindi tayo mapang-aabot eh. So for me, this is based on the code. If ever an authority, it doesn't mean that you're authority, okay, that you could do whatever you want. Do sa US, if they comment my drawing, lagging, okay, they call it plan checker, plan reviewer. So yung mga building official, they are the plan checker. If ever there's a comment, even the inspector, they could not just comment based on their personal opinion. It is always, Engineer Jesse Santos, comment your sheet, E1, comment, reference, code section. It says, kung sila lagi. Kaya nga, if you've been hearing, dun hilig sila sa demanda, sue sila, whatever lagi meron silang. So that's why my topic last year in Metro Central was the top 10 most overlooked code requirement ng Philippine Electrical Code. I'm just advocating. Kasi you will feel more confident if you know the section in the code. Since stopping at the service conductor is required, stopping at the line side terminal would satisfy the requirement of the code. Kung ganyan lang halimbawa ginawa mo, that is the main switchboard of the building, then that is the service disconnect, and then going to tap it on the line side. Is that permitted? No. Tapping at the line side terminal, okay, hindi ko sasabing line side. I said line side terminal is not permitted. So reading the code, pag sinabi kong no, it doesn't mean that sinabi kong no. The code section, ang nagsabi ng no, ang code, hindi ako. I'm just saying no. But in everything that I answer is because sabi ng code, no. Okay. I am also a follower like you. I am not a code author, and this is not the position of IIEE as a whole. This is just, if ever there's a contest, we are okay. We are still friends. We are not here just get the opinion of, also you could consult with the technical committee. So, ito na nga yung setup. Okay, a fire pump shall be permitted by a separate service. Informational note. Okay. Regardless if the electric utility is considered as reliable source or not. Regardless, okay, kung reliable, sinabing reliable, okay. So ito yung kailangan kasi itong what I mean on this one, there might be pag reliable, hindi mo na kailangan. Okay, I need to tweak on my slide here. Ang kailangan lang ng reliable ng another source of power kahit na reliable yung utility mo pag high-rise. I will show on the next slide siguro. So this is a common violation. Okay? That up in fire pump after the service disconnect or the service equipment. Siguro, kung meron nagmimingle na may tanong sa inyo, siguro unahan ko na ng konti. Why the code section does not permit at the feeder to tap for the fire pump power supply? Okay. Kailangan maintindihan muna natin. There are in conductor, sometimes ang slang natin is wire. In a conductor, there are 3 classifications. Pag may nakita kang wire, conductor, my word may be interchangeably, okay? But when I say wire is conductor. Pag may nakita kang wire, you have to know the classification. What are those 3? The service conductor, feeder conductor, branch circuit conductor. Maglalaro dun sa 3. Sometimes, there are practitioner nag-i-interchange. Minsan para sa kanya, basta wire, conductor, energize, whatever. Pero he has to know ano ba pinag-usapan natin. Itong wire na to sige, ano ba pinag-usapan natin? Are we talking of the service conductor, feeder conductor, or the branch circuit conductor? So sinabi kanina on the earlier side, service conductor. So pag tinap mo siya sa feeder conductor, it's not permitted. Why? Sabi kasi, there is no section in the Philippine and National Electrical Code. But in NFPA 20, this is an extracted version or detailed version of 6.95. Sa NFPA 29.2, sabi niya, ahead 6.3.2, the fire pump power supply shall not be disconnected when the power plant is disconnected. This is the reason bakit kailangan itap ahead or before or sa line side ng service disconnect. Kasi pag the intent is, dun nga tayo papatay mo yung power, may sunog You have to disconnect the power of the building. However, kailangan hindi madadamay ang fire pump. The exception permits this only. Pina-permit lang siya kung feeder. Meron lang din siyang isang section na pinapayagan sa isang campus style. Okay. So, in a campus style, there will be slide later na yun naman may certain section na pinapayagan siya sa feeder. Ito yung alternate source of power. Okay? So, in high-rise building, kailangan mo talaga ng backup power, ng alternate. So, the proper word may be instead backup is an alternate source. So, pinakamahigpit, okay, based on my experience, is the high-rise. So, kasi the context always of the code is ina-assessness, of course, is the safety. Mas mahirap. Kasi pag nandun ka sa tuktok, medyo mas matagal kang maka-exit sa building. So another method in this one is self-explanatory about how to power up or make a power wiring para sa fire pump. A total independent power. Then, if I'm going to have a dual electric driven and diesel engine driven fire pump, it is permitted. Mas mahal lang nga. And then for this one, bakit dito pinakita naman is tinap siya sa feeder, not on the service. The answer is because you already complied the diesel, as you have a diesel engine driven fire pump, is already complying sa code. If you just want to add that, you don't have to comply dun sa stringent requirement for tapping of conductor. So you already satisfied. But if you take out this diesel engine, hindi pa pwedeng gantong connection. Now, in 6.95.1.5, what if the transformer is customer owned? Okay. The primary protection of the transformer is therefore customer. There are some electric distribution in a building premise. Ang bumibili ng kasi there are some certain load or demand load, okay, na nire-require gusto ng owner na hindi na kaya i-provide ng utility or cooperative yung ganun transformer. So, for instance, ang Meralco is 2,000 kVA, di ba? There are some cooperatives in the province, minsan 300 kVA. I cannot provide you anymore a transformer sa sabihin ng cooperative. So, mangyayari, you would supply or buy your own transformer. If that's the case, you will still, so if you're going to supply your own transformer, you will not only transform, you will buy your own primary protective device because per PEC 4.50, you need protection on the primary side of a transformer. Different, iba-iba siyang mga protection. So, may isang methodology, there are some pad mount transformer na there are already a fuse on the primer sa built-in already. You could buy that. Or sometimes here may mga practice dito, nasa labas yung meron recloser at the first private pole. Or sometimes ayaw ng service private pole. Kasi after the terminal pole, there are some practice here that ni-require siguro ng Meralco na you have to put adjacent dun sa kanilang terminal pole kung saan kakuha ng power. You're going to install the first private pole. So from there, you also need the protection. If this may be the protection already of the transformer, or if you don't, if utility doesn't care, if mayroon kang first private pole from their terminal pole, diretso na ng medium voltage switch gear for an instant and indoor. So ito na nagpo-protect sa transformer mo. So this is a typical building setup. Just capture this one, okay? Ito yung on the left, from the electric utility terminal pole, so doon magkakaroon ng service point sa inyo at sa iyo yung first private pole. So here, okay, if you have the first disconnect on the first private pole, after that first disconnect, it is called feeder conductor. Pag merong mga kwentuhan, mga discussion, officially man o unofficial, sa trabaho man o hindi. Ayan, yung bumagsak dyan sa concrete pedestal. Ano yan? Service entrance. No, it's a feeder conductor. So, the clue, okay, to make it nursery. Pag service conductor, you do not have any means to de-energize. If the conductor, you have a means to de-energize, you call that feeder conductor. Be mindful, okay? Hindi porket pumasok sa bumaba ng concrete pedestal, what is a service conductor, service entrance conductor. Kaya in any of our discussion, tinatanong ko lang naman lagi, mapapatay mo ba yung conductor, madede-energize? If the answer is yes, that is a feeder. I hope you understand my diagram. I did my best to just an example setup. So if you're going at the upper right, there's the first private pole, and on his left is the terminal pole. So yun yung doon ka magtatap ng para sa fire pump mo. If most likely, pag ikaw bibili ng transformer mo, is the supply would be, they call it primary. So most likely the voltage is 13.2 kV, 13.8 kV. Sa Cebu, there's a 23, 24, and then in Metro Manila is 34.5 kV. So may 13.8 pa rin nata. So 2 ka magtatap. And the problem is, of course, the utilization voltage is not the service voltage. So you have to step down. So this is so beefy. It's so much expensive, but that is the code. Okay, but if you think that is impossible, the owner doesn't have the budget to buy all those things. Yeah, so doesn't mean na dapat ganyan. So you go to another section that permits pwede ka mag-diesel engine driven fire pump. So kaya in my personal opinion, yeah, I do not recommend this kasi it's when, or you could have you try to talk with the utility if they can provide you another service. If we have projects in Metro Manila and other northern part of Luzon. We have more projects that the utility permitted to give another service just for the fire pump. Para 400 volts na lang. If it's 400, 460, or 230. Kasi for this one, for the building, they supply 13.2. So I make a color code, okay? If it's blue, it's a service, it's a feeder conductor. If it's green, it's a service conductor. If it's a little bit violet, yung from fire pump controller to the motor, it is branch circuit conductor. So if not, hindi ka maglalagay ng power fuse sa labas, pwede naman, dire-diretso na yung service conductor mo out from dun sa service point, papunta na dun sa indoor na medium voltage circuit breaker. Kasi required because you have transformer, you have to protect the transformer. And then you have to step down whatever voltage for your fire pump. And then from the fire pump controller to the fire pump motor itself is a branch circuit. Branch circuit means from the last over current protection device going to the load. Kung papunta na siya ng ilaw, papunta na siya ng receptacle outlet mo, that is now called a branch circuit conductor, not a feeder conductor. So most likely, ang feeder is in between 2 over current protective device. I hope I make that clear. So is there a case or exception where the fire pump supply conductors is allowed to be tapped from feeder conductors? So yeah, the only section in the code that permits feeder. So because it's not practical, siguro kung campus style ka, campus doesn't mean it's always school. It might be whatever facility. So kung meron kang, meron isang town center, okay, or flagship, they call it sometimes, may mga shopping center on that area, on that town center. Then magpatakbo ka ng mga underground ng mga distribution line. And then yung pinapayagan naman, okay? So this is a one common setup. This picture came from the National Electrical Code. I just a little bit enhance it so that you could easily understand. So dito, pinapayagan, feeder na kasi dito. Okay. Because dumaan na siya, doon ka na nag-tap sa first disconnecting o sa customer disconnect switch, which is, for this instant, is permitted. Super pwedeng ganito rin ang setup. Okay, you have different source of power. Pwede rin naman one utility source of power or another genset. It is permitted. It is for multi-building campus complex. However, for multi-building campus style complex, okay, you need to, because it's already been tapped to the feeder. So looking at a single line diagram, you need to have a selectively coordination study. Siyempre, you do not, the goal is, pag mamaya nag-fault yung sa isang distribution dun sa main distribution panel, nag-trip and dun sa main, it should be always be closed. Okay? So, we don't want to get into detail. Marami naman siguro sa atin knows about how to run ETAP or SKM, whatever, for your protective coordination study. So you just try to have a coordination. because we do not want to lose power. Okay, or fire pump. That's the intent. The transfer of power, okay, shall be placed inside the pump room. If you have an ATS, okay, so kailangan there's no other location permitted but inside the pump room. Kasi yung pump room, that is a high rated yun eh. Yung room na yun. So, though in PEC and NEC, doesn't not really mention about if fire pump is the automatic. Though sinabi naman sa NFPA 20. Why? Ba't ko sinabi yun? Ako medyo nakaka-confuse ata yung sinabi mo. How should I say this? Because NFPA 20 is not really a mandatory code in the Philippines. So depende. Unless the authority having jurisdiction says that here in, halimbawa for an example, in this city, in this municipal, it is required to follow NFPA 20. So you are permitted to have one disconnect for the fire pump before going to the fire pump controller. So most likely, this kung fire pump mo, magiging service disconnect. Okay, it is considered a service disconnect. So kailangan suitable siya for use of service equipment. In the Philippines, okay, honestly, wala pa akong makitang nagle-label na ganyan. So it doesn't mean na disconnect switch, kahit anong disconnect switch, pwede gamitin for service disconnect. In UL, okay, mga UL listed, mga NEMA standard, no, we're on the IEC already, papunta na tayo doon. But still, the concept is the same. Iba yung pag sinabing suitable for service equipment. May mga barriers sa loob, which nakalagay naman sa Philippine Electrical Code. Kaya nga one of my item and the 1 out of 10 dun sa most top 10 overlook ng PEC is yung sa service equipment. But dito yung service disconnect at yung disconnect ng ordinary is the same. In the United States, is different pag binuksan mo sa loob. So, ano yung pinaka-idea doon? Kasi pag service disconnect, on the line side nun, you cannot de-energize anymore. No, pag something what if you want to repair, maintenance yung service disconnect, hindi mo na mapapatay. It's a safety issue always. Mamaya nagtutunil yung electrician mo, tumama dun sa line side. Pero ang inaayos lang niya dun sa load side, anything can happen. Kaya nga, marami na rin siguro nag-advocacy ng mga arc flash, something. So phase conductor is not permitted. Marami talagang, so may mga phase converter kasi, di ba, na nabibili from single phase to 3 phase. So for this instance, it's not permitted. Okay, it may affect kasi the electronics kasi the fire pump controller, there's an electronics din dun eh. So for how to wire, okay, yung supply conductor. If fire pump supply conductor is considered as service conductor, I hope medyo may idea na kayo. Alam nyo na pinag-usapan natin kanina about service conductor. If the fire pump supply conductor is service conductor, and then ni-route mo siya sa loob. Okay? For example, I mean, ideally, mas maganda if you route outside. But if there is no way, but you have to pass through or route inside the building, it shall be in concrete encased. Fire-rated cable is not permitted. It is based on the code. So, something like that. Okay, a direct connection. So, yung after the utility meter, then pumasok siya sa loob ng building, naka-concrete encased. Pero pag nasa loob na siya ng pump room, you do not need to be in concrete encased. Conductor at the load side of disconnect and overcurrent protection. Kasi nga, you are permitted for the fire pump, one disconnect. Okay, with associate overcurrent protection device. So at the load side nun, of course, mapapatay mo na. You could you it now consider as feeder conductor. And if it's routed inside, a fire resistance rated enclosure construction o fire resistive cable system, pinapayagan na siya. Yung 2-hour na resistant niya. Okay. Pero kung ginawa mo pa rin na concrete encase, it is okay yun, di mas maganda. So continuous power, no? So if lalagyan mo siya ng disconnect, okay, with associated overcurrent protection device. So you have to size up by the lock rotor. So this is now the slide. Or reading at the statement, okay, kailangan hindi siya mag-open within 2 minutes at 600%. Okay. And such thing, okay. But number one is if you size up in lock rotor. So in lock rotor, paano malalaman is the best is what I do in my project is I get the nameplate of that fire pump motor and check ko kung design B ba o letter ano ba, letter A, code letter A, B, C, habang tumatas, okay, may nakita ko G. So you want to be accurate, you have to get that information from the fire protection contractor. Pero, okay, baka may maglalagay dyan. Okay, so kailangan, sabi sa letter D, the trip point for circuit breaker shall not be field adjustable. So pag install na yan, so pag merong mga dial setting doon, adjustment, so gagawin ng iba, hindi, kasi for an example, if the FLC of the fire pump is 100 amp, the full load current, the running load, 100 amp. So by lock rotor, rule of thumb, okay, tina-times nila ng 6. Okay, so lalabas nun, you have to install or you have to specify a 600 amp breaker because the lock rotor times 6. Okay. Kasi meron naman kasi mabibili. There are some breakers that is adjustable. So pwede mo kasing gawin, you're going to install pa rin na 100 amp breaker instead of 600 amp, though i-adjust mo lang yung long time delay. Okay. You could do that, yung mga 250% ng motor na breaker para sa motor. So instead of minsan, you could get away if you do not want to size up yung 250%, just size up 100%. Then lagyan mo na, adjust mo na lang ng long time delay. But for this instance, for fire pump, you are not permitted. So type of cable. So ito na, knowing in concrete in case, pero pag lumagpas ka na ng disconnect, then pwede na ng fire resistant cable, and then pag nasa loob ka na ng pump room, pwede naman ng regular na lang. So, an overload protection really not permitted, okay? Hindi pa pwede, okay, ground fault protection. Kailangan wala, pag may nakita kayo, tanggalin nyo. So, why? Is always keep on saying the motor, no matter what, mag-trip the motor, kailangan it keeps on running. Pag meron ka yan, hindi namatay yung motor. But ground fault alarm, pinapayagan naman siya. Okay. A surge, okay, required naman ang surge protective device. Okay. And then PEC and NEC 700.2, both do not permit stated specifically that a fire pump to be required as emergency load. Where can I find? Kasi big sabihin, parang ganito na. In lahat ng bibigyan mo ng power, kung air conditioning siya, STP pump siya, elevator siya, fire alarm system, ilaw, and everything. The approach is, in what I do that I would like to share to you, you have to list down muna, i-categorize mo siya. And, air condition, is this an emergency load or not? Ito, pwede ba to? Emergency or non-emergency? So ngayon, for instance, for fire pump, may nilagay sa PEC naman na informational note sa 700, sa Article 700. Okay? But it doesn't specify talaga na fire pump is an emergency load. Where can I find? in other codes? Meron ba sa ibang code that it is an emergency load? The only thing na nabasa ko is in International Building Code. Sinabi dito na ang electrically powered fire pump is categorized as emergency power load. Okay. Dito is not really complete in my analysis, but in other countries, okay, ganun din naman ata sa Australia or sa Europe. But in the continent of America, keep in mind mga kasama, the mother of all code is building code. Naka-under lang yung mga mechanical code. So, kahit sabihin, fire alarm, everything, you have to know muna kung required. Ang nagdi-dictate nun, ang building code. Alam mo, sa electrical code, wala naman sinabi doon, you shall have an electrical room. Wala naman sinabing, kailangan may word muna na shall. Sa building code, sinabi na, you shall install smoke detector. Ang medyo kakambal nito is the fire code. Okay. Pag sinabi niyang building code on fire code na you shall install smoke detector, and then the NFPA 72 or the Electronics Code of the Philippines does not kailangan siya magre-require na ito lagi mo to. NFPA 722 will just tell you how to install it. Kung paano yung range, yung layout, everything, yung distance, everything. So, dito, ang nagsasabi, this is what we use before going to National Electrical Code. In my experience in the United States, is go by the building code muna. Try to define it. Anong type of, pag you're going to install or construct or design, number one approach, keep in mind mga kasama, is to know muna the type of occupancy. Ano ba yung gagawin ko? Tatanungin mo muna siyempre sa client, ano ba yung gagawin? Meron akong paggagawa. Ano ba paggagawa mo? Diba? You have the first question lagi na ano ba paggagawa mo? Doghouse ba yan? O anong type of occupancy? From there, you could filter by the building code kung anong mga requirements. Why? Because in 7.0.2.1b5, pag emergency load kasi, at we're talking of the emergency source, you cannot mix the circuit breaker or disconnect ng para sa emergency, legally required standby, for optional standby. Kasi whatever happens, ang priority nila dito, if ever hindi kakayanin ng genset, is ang bibigyan muna ng top priority nila dito is those emergency load. So baka pinag-mix natin and it is not a reliable. May mga bagay na wala ng power doon sa ospital, pati yung respiratory, nawala ng power, hindi na nakahinga yung pasyente. So, there are things na, for emergency, rule of thumb is around 10 seconds, mabigyan mo na siya. But there are some cases that you need faster than 10 seconds. Halimbawa, data center, wala na you have to keep it going. Well, there's no 0.1 seconds. So, kung di naman kaya ng genset, siyempre, you put a UPS. So, criticality is very important in electrical. So for this one, it's a setup, okay, na yung ATS ng para sa fire pump, nakahiwalay siya at hindi siya kumuha dun at the same circuit breaker of the genset dun sa mga ATS para sa non-emergency load. How about the power wiring, okay? Ganun din naman, you might need a control wiring. May mga control wiring, mga ATS, fire pump controller, synchronizing panel, genset, everything. So for this one, hindi basta magpatakbo ka lang ng control wiring. Okay? It should be a 2-hour minimum fire rated assembly. General rules, okay? Medyo patapos na tayo. So general rule, so short circuit protection only. Okay. So overload is not. Ground fault protection, not permitted. Okay. So kailangan restriction ng 2.40 shall not apply. Okay. No overload protection. Kailangan itap mo siya sa service conductor. And then yung conductor need to be routed independently from all other wiring and protected from all potential damage by fire, structural failure, or operational accident. However, but not from fire pump motor overload. Summary, okay? It is a common standard operating procedure to turn off the main switch of the building during major fire. Fire pump power supply shall not be affected when turning off the main switch of the building. Be mindful, okay? Bakit ganun? Nasa protocol naman ng engineering department yan, ng operational department yan ng building. Be mindful. We have human conditions. Nangyayari yan. Okay? We forget things, especially our adrenaline rush. During the building is under major fire. Kaya nga pag may sunog, yung refrigerator, nang bumubuhat ng isang tao. Pero pag normal condition, hindi naman niya mabuhat. So we have adrenaline rush. Natataranta tayo. So mitigating the reason that in the event of pump is not running anymore due to loss of power supply. We try to mitigate. The code does not say, kahit ako, okay, my opinion, there is no guarantee. We are just trying to mitigate. We're trying to lower the chance of failure. Okay. Okay, my ending maybe is sharing to you the message of the president of NFPA. Sabi niya, I believe we have now let it get to the point where people take standards for granted. Yes, they still exist and are implemented when buildings are being constructed. But we at NFPA, I believe this is also the advocacy of IIE, are trying to raise the level of awareness surrounding these standards by constantly providing information, by staying relevant to today's issue. So hindi ako titigil na magsalita, sisigaw at sisigaw ako. We have a safety rules about in terms of I don't want to imagine na ayoko nang makakita talaga what happened to us when we were not prepared nung nagkaroon ng COVID. So sabi din ni Jim Poley nung in-interview siya last year, sinasabi niya, ayun ang problema sa mga tao. It's an issue when it's already an issue. Again, I want to say happy birthday to my dad, okay? Kasi yung late na Jess Santos Sr., he is the father of 400 volts in the Philippines. So I am the son, I am maybe different, I have my own advocacy, but the concept is the same, okay? I want to share to you my knowledge, and then if there's any question, you are open to ask me question. Again, thank you very much. And I'm going to give back the floor dun sa ating MC. Maraming salamat sa inyong lahat, and I hope you enjoy the rest of your morning.
Thank you very much for your for sharing your knowledge, sir, and for sharing your experiences to our delegates this morning. And to our delegates, Sir Jess will still be here with us to answer if you have any question. And at the end of the presentation today, at this afternoon, the three speakers will answer all your inquiries. So for now, thank you very much, sir, and let us now present your certificate of appreciation, Sir Max Adarlo. Hello, Sir Max.
Institute of Integrated Electrical Engineers of the Philippines, Accredited Professional Organization, Certificate Number IAPO-016, PRC accredited CPD provider number OEE-2020-007. This certificate of appreciation is presented to Engineer Jesus N. Santos Jr. for imparting his knowledge and expertise as resource speaker on the topic Power Pump Code and Intent via Zoom, given this 12th day of June 2021. Signed by Engineer Joseph Darren Claire S. Sulicar, Chairman, IIEE Training and Continuing Professional Development Committee, and signed by Engineer Alan Anthony P. Alvarez, 2021 IIEE National President. Thank you once again, Engineer Santos. Any few words for the acceptance?
Thank you very much. Thank you very much, sir. So, thank you very much, Max. So, once again, okay, I am continuing to shout out our Philippine Electrical Code that siguro ganito, my last word is, if there's someone who read the codes, I will guarantee you, now I will say the guarantee, how I love my code. You ask question, then I may not memorize all the section, but I will tell you if it's in the code or not. So that is my advocacy. Okay, salamat sa inyo one more time. Back to you again.
Okay, sir, can you just take a post, sir, so we can have a screenshot of you receiving the e-certificate? Okay. 1, 2, 3, smile, sir. Thank you very much po. Okay. So, another one na po, sir. So, 1, 2, 3, smile. Okay. 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 Okay, so there you have it. Thank you very much, sir. From one outstanding speaker to another, to formally introduce
Hello.
Yes, sir, Max.
Okay. Sorry for that. Okay. Our next technical speaker is a professional electrical engineer. He is currently the Assistant Vice President of SMEDD Operation. He is the former President of IIEE Metro South. He served as the MMR Deputy Governor of IIEE Metro South and Vice Chairman of the IIEE National Committee on Energy Efficiency. Let us all welcome Engineer Charles L. Singson.
Yeah. Also, morning to everyone. Can you hear me?
Yes, sir, we can hear you, sir.
Max, thank you very much for the great introduction. Yasmin, thank you. So it is my pleasure to be with you here today. But instead of listening, we are doing the talking. I love very much what Engineer JC Santos has said kanina. Ang sarap kausap si Engineer Santos. He's a very intelligent engineer. Madami kang matutunan sa kanya once you have a chance na makausap mo siya. Buti nga lang at nagbalik bayan siya. Kasi nung kakwentuhan ko yung tatay niya dati, ang sabi ng tatay niya is meron akong anak na electrical engineer pero parang hindi interested na magtrabaho dito sa country natin. So thanks kay Engineer JC at bumalik siya na merong dalang-dalang international knowledge about lalong-lalo na yung mga natin, fire protection. yung discussion on fire pump is malawak na until now, ang dami pang nalilito. So, ang daming interpretation sa mga yung topping point, yung pinipresent kanina ni Engineer Jesse Santos. So, thank you, Engineer Santos, JC, for sharing your knowledge.
Salamat.
Almost 1,000 tayo ngayon at nakakataba ng puso dahil nakita kong meron tayong mga attendees na from Dumaguete, Tagum City, Cebu, Davao, among other regions. At ito yung kagandahan ng virtual presentation. Madami tayo nabigyan ng information across the country. At titignan ko yung mga Q&A kanina, daming magandang question. So, Engineer Yasmin, siguro paki-consolidate lang lahat para later masagot namin lahat yung mga questions nila. At the same time, natututo kami sa mga questions ng mga listeners natin. So, I have presented this same topic last March 13 in our IIE Metro South webinar series. Then our Engineer Julius Saraco, ang IIE TCPDC. TCPDC means Training and Continuing Professional Development and Committee. Nag-send siya ng message sa akin kung pwedeng i-present sa inyo itong topic na to. So sabi ko sa kanya, sure, no problem. So actually, ang binigay ni Engineer Julius na schedule sa akin is May. Okay? So, nag-request ako sa kanya na baka pwedeng gawing June 12. Not that this day is holiday, Happy Independence to all pala, but the title of my topic is 400-volt system. And ang sabi nga kanina ni Engineer JC, si Engineer Jess Santos, yung father niya, is popularly known as the father of 400 volts. And we want to dedicate this presentation in the commemoration of the late Engineer Jess Santos. At birthday niya ngayon. Happy birthday, sir! Okay. So,
Pagdating sa kanya. Oo.
Moreover, I would like to thank our TCPD Chairman Joseph Solicar for giving me this opportunity to share also our thoughts and learnings to our IIE members across the country. So the good thing of being a presenter is that you cannot just share your learning to others, but also you can gain learnings from the attendees, lalong mamaya siguro yung mga Q&A. Hence, I am encouraging other members to also share their expertise to others, especially yung mga seasoned engineer, yung mga punong-puno na ng knowledge about the application of electrical engineering. So, since our topic is entitled Effective Grounding of a 400 volts electrical system, this can be discussed in a very short time. So, I have injected other items as an icing. So, share ko lang ngayon yung presentation. So, have you seen my presentation na? Nakikita na?
Yes, Charles.
Okay, thank you. Okay. So, the reference of my discussion, so ito yung mga icing naman, kasi yung recommended grounding for a 400 volts 5-wire system is a very short topic. So, nag-inject ako, pag-uusapan natin about the grounded conductor, neutral conductor, grounding electrode, what is ungrounded system, ano yung pero-resonance effect of ungrounded system, yung grounded system, bakit tayo gumagamit ng 400 volt system, ano yung advantages, ano yung K-factor rated transformer, then we'll go to the yung main topic natin, which is the recommended grounding for the 400 volts 5-wire system. Okay? So the reference of my discussion, okay, so siguro tanggalin ko lang muna yung video ko para yung bandwidth hindi affected. Okay, sadali lang. Okay, ano mo matanggal to? Okay. Ayan, okay. Dali lang at inaayos ko lang ito. Okay. So the reference of my discussion is more on PEC because later there will be another speaker who will take up the banding and grounding in reference to IEC. Okay. When something is grounded in accordance with the NEC PEC, it is connected to ground. or to a conductive body that extend the ground connection. Okay. Some grounded conductors are also the neutral conductors. For UK and IEC, they call the grounding system as the earthing system. So mamaya, mas malawak yung discussion siguro dito about IEC mamaya. That connects specific parts of an electric power system with the ground. Typically, yung the earth conductive surface for safety and functional purposes. Okay? So one of the most misunderstood and confusing concept is the difference between yung banding, ano ba yung grounding, earthing. So yung banding is a more clear word compared to the grounding and earthing. So there are actually different terms for expressing the same concept of the grounding and earthing. Okay? So grounding and earthing in a main electrical wiring system is a conductor that provides a low impedance path to the earth to prevent yung mga hazardous voltages natin from appearing on the equipment, lalong-lalo na pag may mga insulation failure ka. Okay? So grounding is the word used in North America standards. That is yung NEC, IEEE, ANSI, UL.
Charles, hindi yata nagta-transfer yung slides mo. Naka-maintain doon sa first page pa rin.
Okay. Sorry. Mabagal yata. Yeah. Dali lang. Siguro tanggalin ka lang ulit tapos i-refresh ko. Okay, sandali lang. Okay. Share. Sandali lang Parang nawala sharing ko. Wait lang.
Okay, so while Sir Charles is sharing his screen again, we just would like to remind our delegates that you don't have to leave your email address on the chat box since we have a record of those who attended this webinar. So therefore, yung mga registered email addresses po ninyo is dun po kami mag-send ng presentations once na may na-share po yung ating mga speakers. So ayun po. And regarding po sa certificate, nire-request lang po namin yung mga delegates po natin na sana mabigyan po kami ng counting time, at least 10 working days po to work out on your e-certificate since kailangan pa pong ma-generate ng mga attendances and records for this specific webinar, and also we still need to comply with the CPD requirements para po magkaroon po kayo ng CPD points. Ayan po.
Yasmin, nakikita
Okay.
na Yasmin?
Sir, right now hindi po nakashare ang presentation. Yung Windows po yung nakashare.
Okay.
So ayun, may nag-leave pa rin po ng email address dun sa chat box. No need
Okay
to
na.
leave your email
Sir Charles,
address.
okay na. Nakikita na.
Yes po, okay na po, Sir Charles.
Pero ayaw mag-transfer. Sadali. Okay. Wait lang ba't ayaw? Okay. Pwede na. Okay, so... Okay. Narinig ako, Yasmin, narinig ako?
Yes po, sir.
Okay, so yung grounding means connecting the live part to the earth. So it means the part which carries yung current under normal condition. As an example is yung neutral power ng transformer. So it is done for the protection of power system equipment and to provide yung effective return path from the machine to the power source. Yung earthing means connecting the dead part to the earth. So it means the part which does not carry current under normal condition. So as an example is yung electrical equipment frames mo, yung enclosures, yung mga supports. So under the fault condition, yung non-current carrying metal parts mo of an electrical installation such as frame, enclosure, may attain high potential with respect to ground. So any person na makahawak dun sa kan mo, sa metal parts na yan, which will result to yung flow of current to the body. So, okay, so delikado yan. As an example, okay, yung figure 1 natin, okay, so yung line 2 mo, of a single phase transformer to, yung example natin. Yung line 2 mo, yun ang naka-ground, okay? So, so ito yung in this particular case, we call this system as a single phase 2-wire line to ground or line to neutral 230 volts. Pag measure mo yung line 1 to ground, 230. Pag measure mo yung line 2 to ground, 0 volts. Ito yung electrical system na naka-install sa bahay ng lolo natin sa probinsya. Yung service point is an insulated wire for the ungrounded phase conductor, yun yung line 1, and uninsulated naman yung isa, yung grounded conductor. So please note that the neutral of this transformer was not utilized. Okay? They called is floating neutral. Yan, tignan mo yung right side na photo. So naka-float yung neutral niya. Okay? So in figure 2, okay, yung line 2, yun yung naka-ground. So naka-band yung line 2 dun sa body ng transformer. Okay? Dun sa figure number 2 natin, okay, the neutral is connected to ground. In this particular case, we call this system as a single phase 3-wire system. So yung line to line mo, 230 volts. The line 1 and line 2, yan yung 230 volts mo. Yung line 1 and ground or line 1 to neutral, 115 volts. Okay? Yung line 2 to ground mo and line 2 to neutral, 115 volts. Okay? May kwento nga si Jesse sa akin dito nung present sa Metro South. Way back kasi madami yung mga dumadating na mga appliance natin dito sa Pilipinas. Yung iba galing sa USA where the rating is 110 volts. Ang term nga natin nung araw dito is made in USA. Yung other appliances naman from other countries which are 220 volts. Yung mga galing sa Spain, Germany. So of course, magagaling yung mga Pinoy engineers natin. And what they did, they connect and utilize the neutral of the line-to-line single-phase transformer para makapag-produce ng 115, para makater yung mga 110 appliances which is made sa USA. Then, that is yung line 1 to neutral mo is 115, line 2 to neutral mo is 115. On the other hand naman, okay, the line-to-line ng transformer is 220 volts. So para sa mga appliances natin ng mga 220. So, yun, solve yung problema sa iba't ibang different voltages of our appliances. But which is better to use? Siguro let's talk about safety, okay? Ito pala yung line ko natin, figure 2. Yung grounded conductor mo na, yung neutral mo, yun ang naka-ground. Okay? Okay. So, pag-usapan natin, itong ano ba yung mas safer to use. So, when you do the maintenance of the lighting fixture in figure 3, at tinatamad ka na i-open yung circuit breaker before doing the troubleshooting of fixing the lighting fixture, you are potentially exposed dun sa 115 volts, electrical shock hazards. So, most especially, hindi ka nakasuot ng sapatos, nakapaapa ka lang. Okay? So, unlike figure 4, which is the line to ground or line to neutral, once the switch is off, you can now do the maintenance of the lighting fixture without the hazard of electrocution. So now, which is better to use? Okay? Safer ba yung figure 4, which is the line 2 that is grounded to establish a zero potential to ground? So mas safe ba yung bahay ng lolo natin sa probinsya? Si Meralco have still this configuration with some of their installation. Meron ako kakilala sa Dasmariñas Village that they have this kind of system. Yung line to ground, 230 volts. Yung line 2 to ground is 0 volts. So parang line to neutral. Pero sa probinsya natin, yung mga electric cooperatives natin under the National Electrification Authority, they have this line to ground system like in figure number 4. Okay. Okay, ito naman yung common mistakes of banding the neutral of the primary and secondary. Okay, so yan, mga common mistakes. Okay, so this is the case where the banding of the neutral primary to the neutral secondary of the transformer. Meron din ako na-witness na ginagawa ito sa three-phase YY distribution transformer. Yung neutral ng primary, binand sa neutral ng secondary. Okay, let's take this figure to explain further. Okay, so a lineman was asked to place an ammeter dun sa primary phase conductor. Diyan, pinakuha. The lineman has said that his reading is 42 amperes. Then he was asked again, anong reading mo sa neutral? 22 amperes daw. So so tinanong uli siya, saan pumunta yung pan? Yung another 20 amperes. Dapat kung 42 yung pan mo, yung phase mo, dapat yung neutral mo is 42 din, di ba? So dito napunta yung 20 amperes mo. Yan. Okay? Hence the right connection, ayan, ginawa sa kan, totoong installation yan. Nag-common yung primary and secondary neutral. Okay. So ito dapat yung tamang installation. Nakaseparately derived yung neutral connection ng secondary sa primary mo. Hoping that there is no violent reaction and that we will have a common agreement on this. Okay. So next. Okay, so ito yung presentation ng mga grounded conductor for a three-phase system. Okay? Yung figure 7 natin shows a Y secondary where the neutral point is grounded. So in the past, the low voltage systems, yung mga 600 volts and below natin, have almost universally and predominantly been connected to delta secondary transformer. So it was sometimes advocated that one of the line be grounded as in figure 8, ito, corner delta grounding. Okay? This was done in order to obtain some of the advantages ng grounding the system at a minimum capex expenditure. But because of its limitation and disadvantages, so it is now strictly compromised method and is rarely encountered in modern days electrical installation. Though madami pa din yung mga installation na ganito sa atin. Yung delta connected secondary installation. One of the outstanding disadvantages of a corner of a delta grounding is yung necessity for positive identification of the grounded phase throughout the entire system. Mahirap magkamali ng tapping point. Also, yung mga instruments mo, meters and relays should not be connected dun sa mga grounded phase. So yung solution ng ganitong mga installation, instead of corner grounding, so gumagamit sila ng dry type zigzag grounding transformer para makapag-establish ng neutral for the delta. Okay? So pag ungrounded conductor, so ito yung kanya definition, not connected to ground or to conductive body that extend to the ground connection. Okay. Okay, so next. Ito yung neutral point. Ito yung mga definition na nasa PEC natin. Neutral point, yung common point on a Y connection in a polyphase system. Or yung midpoint ng single phase free wire system. Or yung midpoint dun sa delta system mo. So yan yung mga neutral point. Okay? Okay, next. Neutral conductor naman, the conductor connected to the neutral point of the system that is intended to carry current under normal conditions. Yan yung figure number 9, yung may neutral ka. Okay? Okay. So yan, nakapag-establish yung neutral mo, ang purpose niya is to establish yung zero voltage fan mo, reference, and dapat magkaroon ka ng return path. Yan, yung purpose ng neutral. Okay? Okay. So, yung the grounding conductor has a zero voltage just like the neutral conductor, diba? But it have a different function. As implied by its name, this conductor provides a grounded connection for all appliances and equipment. Okay? Itong figure na to, under normal conditions, all the current returns to the neutral conductor. Okay? And the grounding conductor, walang dumadaloy na current dyan. But when a line fault occurs, yung grounding conductor provides a return path for the fault current. Ayan, ayan. Pag may insulation failure ka dun sa picture, so yung current mo will flow dun sa equipment grounding conductor mo na. Okay? So without the grounding connection, appliances and equipment become energized if a live wire touches them accidentally. So this fault will not be disconnected since yung protective devices can only respond when there is a fault current in a grounding wire. Kasi kung walang dadaanan yung fault mo, hindi ka makikita ng protection mo. Okay? So ito, delikado to, yung mga wala kang mga equipment grounding connection. Okay. Next. Okay, so figure 15 is a representation of a delta Y distribution transformer. Okay, sa Meralco franchise, yung left side mo, yung sa delta supplied by 34.5 kV primary. Yung sa secondary mo, 400 volts 5-wire secondary. Yung neutral point of a Y secondary is connected to the grounding electrode conductor, down to the grounding electrode. Sa IEC uli, they call the grounding electrode conductor as earthing conductor. While yung grounding electrode mo, yung tinatawag nilang earth electrode. Okay? So yung left side, wag yung kakalimutan na lagi ipasok yung grounding ni Meralco or neutral ni Meralco dun sa substation nyo. Kasi pag wala yan, if you have a fault dun sa primary mo, hindi makakabalik dun sa system ni Meralco. So very important na yung pumasok sa building mo is laging 4 yan. Line 1, line 2, line 3 plus yung neutral wire nila. They call it grounding wire. Okay? Okay, so ito, gusto ko lang i-emphasize. Today, there is no such thing as delta-delta or y-delta. Okay, except for some special applications like yung kung meron kang very critical loads na ayaw mong mag-trip kagad, yun, ginagamit ng delta. I do not know kung sa hospital, airport is naka-delta pa rin secondary. So the Y secondary is not only the predominant choice, but because it is the standard itself. Okay. Okay, ungrounded system. Okay. Yan yung ungrounded system mo. Merong figure 6, naka-Y siya, pero wala siyang neutral naka-ground. Yung neutral point mo hindi nag-extend sa grounding rod mo. So what will happen kaya if the electrical contractor had forgotten to connect the neutral point to the transformer, Y secondary to ground? Okay, there would be a floating voltage. Kasi meron kang imaginary ground dyan na kahit hindi ka nag-establish ng high magandang grounding, nagkakaroon ka ng high impedance grounding. Yan yung imaginary ground mo. So a broken neutral on a three-phase transformer will cause yung voltage to float up to the line-to-line voltage, depending upon the load balancing of the system. So this type of neutral floating may damage yung mga customer equipment connected to the supply. We have experienced this scenario. Nakalimutan ng contractor na i-ground yung neutral. So, ang daming na-damage ng mga DDC. Kasi yung nagkaroon ng line-to-line, yung line-to-ground mo, pag measure mo, nagla-line-to-line na. So, very important not to forget na i-connect yung neutral of your Y to the ground para wala kang floating voltage. So, yan. This situation can be very dangerous and customers may suffer serious electrical shocks if they touch something where electricity is present. Okay. So kasi pag naka-float yung neutral mo, hindi magti-trip yung mga breakers mo dahil number one, wala kang return path. Tapos number two, yung current mo na yan, yung line to ground current mo is napakaliit na hindi makikita talaga ng system protection mo. So sisirain niya yung insulation mo pag meron ka mga system na ganyan. Okay, ito yung theory of overvoltage ng ungrounded system. Okay, pag yung RYB mo, yung line 1, line 2, line 3 mo, yung R nagkaroon ka ng fault, so kaya insulation failure, so yan, may babalik na current through the capacitive mo, yung imaginary ground mo. Magkakaroon ka ng yung IG, formula niya, square root of 3, tapos yung IG prime mo, yung bumalik na kasi may fault yung R mo, wala kang current dyan, may bumabalik dun sa mo Y and B mo, okay? So, nagkakaroon ka ngayon ng yung unstable voltages pag bineasure mo yung R mo to ground, 0 volts yan, pero yung Y to ground, B to ground mo, mataas yan. So ito, the voltage across the healthy phases is now 3 times or 73% more than the phase to neutral voltage under healthy conditions. So yung under certain line to ground impedance condition, when the ground circuit may also contain some inductive reactance, the voltage of the healthy phases may rise further, much above the system voltage due to the resonance or ferro-resonance effect. So nangyayari yan kasi yung inductance mo is yung coil ng transformer mo. Asan yung capacitive mo? Yung capacitive capacitance ng cable mo. So pag nag-series siya, nagkakaroon ka ng yung ferro-resonance effect. Paano ba nangyayari yung ferro-resonance effect? Yung magnetic flux mo dun sa coil ng transformer mo, pag bumaba yan, di ba, parang nagpa-fluctuate yung magnetic flux mo, sinusoidal, i-charge niya capacitor. Pag yung capacitor mo naman, pag discharge, i-charge na yung inductive mo o yung coil ng transformer mo. So parang pendulum na yan. Parang pendulum. Yun yung reason why nagkakaroon ka ng overvoltage. Okay. Summary of ungrounded system. Okay, yung electrical power systems which are operated with no intentional ground connection to the system conductors. Okay? Pero in reality, these systems are grounded to the system capacitance to ground. Yan. Okay, yan yung imaginary ground mo yan. Okay? In most cases, this extremely high impedance and the resulting system relationship to ground are weak and easily distorted. Kaya nagkakaroon ka ng fluctuating voltage, high voltages. Nawawala yung normal voltages mo. Okay? Excessive overvoltages can occur during arcing, resonant, or near resonant ground faults. Yung capacitive current is responsible for producing yung arcing grounds. So this capacitive current flows because capacitance exists between its line and earth. Yung yung phenomena of capacitance, yung mga underground cable natin, ng mga XLPE, yan, mataas ng kanya. capacitance. Okay, so emphasis, ungrounded electrical system are most commonly subject to overvoltages. Okay, so it is very important to recognize that ungrounded system are actually capacitively coupled to ground rather than divorced from the ground. Okay, ito yung effect or impact ng overvoltages in the event of ground faults in an ungrounded system. So sa delta, 5 to 6 times the normal voltage on the unfaulted phase. Kaya pag nagme-measure ka ng voltahe, yung line 1 to ground, line 2 to ground, line 3 to ground, may nakikita ka minsan na matataas na voltage. Yung Y system mo, 15 to 16 times the normal voltage of the unfaulted phase. So despite this, the ungrounded system will not trip any breaker or fuse during the single line to ground faults. Hindi makikita ng protective devices natin dahil wala kang return. Okay? So ano ba yung advantages ng ungrounded system? So two principal advantages are attributed to the ungrounded systems are the following. Yon, yung operational. Pag nagkaroon ka ng first ground fault on the system, hindi ka pa rin magti-trip. So pwede mo pa rin gamitin yung system mo. Maghihintay ka lang ng isa pang fault dun sa isang line mo in order to trip yung breaker mo. Okay? So economics. No expenditure are required for grounding equipment or grounding system conductors. So nakatipid ka nga. Yung sa down conductor mo, wala. Yung grounding rod mo, wala. So economics. Ito yung actual examples. Dry type transformer delta-delta. So 500 kVA, 460, step down to 230 volts. As you would observe, yung line 1, line 2, line 2, line 3, line 1, line 3 are all normal. Pero pag mineasure mo na yung line 1 to ground mo, yan, instead na, example, 115 dapat yan, di ba? O kaya na somewhere sa 120. Yan na yung nakukuha mong voltage. Nag-i-equate na sa line to line mo. Tapos yung isa, line to ground, 0.2 volts. Yan yung may tama. Okay? So another example, ito naman yung, ito yung normal. Malinis yung insulation ng cable mo. Unbalanced lang, no? Okay. So ungrounded system, delta secondary. Some of the solutions para magkaroon ka ng when an ungrounded system is chosen, yung ground detection scheme may be applied. So this scheme frequently takes the form of three voltage transformer with their primary windings connected in Y and with the primary neutral grounded. The neutral windings of the voltage transformer are usually connected in broken delta with a voltage relay connected in an open corner and used to operate an indication or alarm circuit. Yan. Yung mga samples. So pag naka-delta ka, pwede kang mag-install ng Y open delta. Tapos doon sa open delta mo, may icon ka doon, pilot lamp ka o ilaw as indicator na may problema yung system mo kung may fault yung isang line. Para yung over voltage relay mo mag-trip din, yung 59G. So another solution is yung zigzag transformer. So yan, para magkaroon ka ng neutral. Okay? So linalagyan lang nila ng loading resistor. Anong reason, anong purpose nito? Yung loading resistor mo, siya yung protection mo para maiwasan mo yung mga pero resonance sa system mo. Para may nag-absorb, may resistance ka nag-absorb to avoid yung pero resonance. Okay, grounded system. Yung grounded system, a system of conductors in which at least one conductor or point, usually the middle wire or neutral point of a transformer or generator windings, that is intentionally grounded, either solidly or through an impedance. Ito yung mga typical system of grounding. Okay? Di ba napapansin nyo, pag 34.5 solidly grounded. Tapos pag yung mga 416 kV natin, yan, may mga resistance grounding. Low resistance or high resistance grounding. Tapos doon sa low voltage na, yun solidly grounded. Okay? So advantage of grounded system, greater safety, no excessive over voltages, mas madaling i-detect yung fault and mas madaling mag-troubleshoot. Okay. Yan, punta na tayo sa 400 volts. Why 400 volts? Okay. So, yan. Cost avoidance on the core and copper loss. Kasi wala ka ng dry type transformers. So, less core and copper loss sa system mo. Savings on electrical panel board. Compute namin yung approximately 30% cost reduction. Okay? Safety on the lighting fixtures and power fixtures during the necessary maintenance. Tulad ng pinakita ko kanina, na pag pinatay mo yung switch, wala ka ng potential, hindi ka na magkakaroon ng yung line to ground na mataas. Simple electrical configurations. Okay? Marami pa. Okay. So, yung cost avoidance, ito na yung why nakakapag-save tayo when we use yung 400 volt system. So, with this presentation, ito yung 400 volts mo. Simple diagram. Okay. Another system, merong kang 34.5 460 volts. Tapos nag-step down ka pa to cater yung mga lightings and power sa 230 sa either delta Y or delta delta. Tapos yung 460 mo, direct na sa mga electric motors. Okay? So yan, ang installation mo, yung may distribution transformer ka. Okay? Tapos magkakaroon ka ng mga dry types transformer. Okay? So yun, meron kang core loss, copper loss dyan for the dry types. So rule of the thumb, 0.8% yung copper loss, 0.3% yung core loss. Pag kinompute mo na ngayon yan, so example, 2,000 kVA. So 1,900 kilowatts, so power factor mo is 95%. So yung core loss mo, with the rule of the thumb, meron kang core loss na 5,700 watts. Copper loss, meron kang 10,640 watts. Okay? So pag kinompute mo na, ayan na, gagastos ka sa losses ng 66,000 per month sa 2,000 kVA. Yung total, example, may 2,000 kVA ka na total na dry type. Kaya ang dami mong buildings na ganyan. So ang laki yung cost mo for the OPEX. Okay? So savings on the single phase panel board. So lighting panel board, yung line to line, yan yung kanya, yung itsura niya. So mas simple na line to neutral kasi single pole na lang yung gagamitin mo. Tapos magkaroon ka lang ng neutral bus, magkaroon ka lang ng grounding bus. Okay? Yan yung line to neutral mo. Okay, so that's line to neutral. So as you can see, yung neutral mo is different dun sa equipment grounding mo. Equipment grounding conductor mo, walang current during the normal operations, normal condition. But when you experience abnormal condition, may fault dun sa load, may insulation failure, diyan nadadaan sa equipment grounding. Okay. So safety on lighting. Okay, so mas safe yung line to neutral dahil pag pinatay mo na yung switch, wala ka ng exposure dun sa potential difference or voltage. Yan, simple. Mas simple siya yung 400 volt system. Okay, question. Okay, yung mga kasagot dito sa question na to, dalawang question lang to. Unahan lang yung mga kasagot ng tamang answer. Then I will request Yasmin to get yung GCash para doon natin ihulog yung 1,000 kung sino first na
Wow.
makakasagot. Okay.
Okay po, so paunahan sa chat box, sir. So sino
Paunahan
pong
sa chat
unang
box.
makakapag-send?
Yes.
Okay, sige po.
Okay. Question number 1. Okay, so delta Y. So 100 amperes yung line 1, 100 amperes yung line 2, line 3 100 amperes. Anong voltahe yung neutral? Anong current pala yung neutral? Sorry. So,
Okay.
yan. Sagot. Yasmin, kung lang pakita nila kung may nauna. So yung first pa, kung marami na nakasagot. Saka yung kung sino na unang sumagot, anong sagot, Yasmin?
Puno.
Matagal sumagot ah.
Ayan po, Sir Bobby Lubos.
Anong sagot, Yasmin?
Ang sinagot niya po ay Z. Pero po walang unit. Acceptable ba yun, sir?
Okay lang, okay lang.
Okay po.
0 amperes, okay. So next question. Basta yung ang natin dito rule, yung dalawang sagot, yung unang engineer na makakasagot ng tamang dalawang question. Yan. 125 yung line 1, yung line 2 150, yung line 3 130. Ano yung neutral current? Pwede ko lang i-post yung sagot.
Engineer Charles, nawala po yung net sa office. Saglit lang po.
Okay, Max, thank you.
Ayun, hello? Hello, sir? Can you hear me? Oh, ayun po, for the second question po. Let me see. Ang pinakaunang sumagot po ay from Sir Ezzy Kayas. Ang sagot niya naman po is 45 amperes. Is that correct, sir?
Ang sagot is 22.91. May nakakuha.
Oh, meron pong nakasagot si Sir Yulehio. Ayun, 22.91.
Ay, yung number, yung
Ayun.
first question niya, anong sagot niya? 0?
0 po.
Oh, so siya yung winner.
Ang sa pangalawang question po, ang nakasagot po ng 22.91 ay si Sir Eulogio. Magkaiba pong tao, sir, yung nakasagot ng number 1 question and number 2 question po.
Yasmin, i-check mo na lang yung kung sino yung nakasagot ng tama.
Okay
first
po.
question, tapos i-Viber mo na sa akin, kunin mo yung GCash account niya para doon ko ihulog yung 1,000.
Okay po, sir. Okay po, sir.
Okay, so this is the formula. Pag hindi nyo kabisado yung formula ng pagkuha ng neutral at wala kang tester sa site, so okay, nakuha mo lang yung line 1, line 2, line 3, yan yung formula ng pagkuha ng I neutral mo. Okay? So drawback ng 400 volts system, yung triplen harmonics. Okay? So yung neutral current is distorted by harmonics. Okay, so yung facts ng three-phase four-wire system na neutral conductors can severely affected dun sa nonlinear loads connected to 230 volts branch circuit. So under normal conditions for balanced linear load, the fundamental frequency is 60 Hertz. Okay? So kinakancel niya yung phase current will cancel the neutral conductor. Okay. So in a four-wire system with single phase, nonlinear loads, certain odd numbers harmonics called triplen. Ito yung mga odd multiples of the third harmonic, yung third, 9, 15th, so etc. Hindi nagka-cancel to, but rather nag-a-add dun sa neutral conductors mo. Okay, so ito yung fundamental natin, yung 60, yung tamang natin, sinusoidal. So meron tayong 120 degrees phase angle, okay? So ito yung positive sequence mo. So 120 phase angle. Ito yung negative sequence mo. Okay? Okay. So yung red, yan yung fundamental mo, 60 Hertz. Pag may third harmonics ka, yan, may distortion ka dyan. So instead na maganda yung sinusoidal mo, nadi-distort. Okay, so ito yung presentation niya. So yung fundamental mo, may phase angle siya na 120, but as you can observe, yung harmonics mo, yung third harmonics mo ngayon is naka-in phase siya, wala siyang phase angle. Ayan, no? Okay? So, kaya tinatawag nilang pa niyan, since wala siyang phase angle, tinatawag nilang zero sequence. Okay, so anong nangyayari dyan? So, neutral current in a balanced fundamental is zero. Kung balance yung fundamental mo. The neutral of a balanced third harmonic current coincide in phase and time. So, nag-a-add siya, 300% of the phase third harmonic current. Ayan, yung parang representation niya. Yung neutral mo, since zero sequence yung triplen harmonics mo, mag-a-add dun sa neutral mo yan. Okay. The triplen harmonics on the secondary Y of a transformer are in phase. Hence, they add in the neutral. Yan. Yung delta Y mo, so since meron kang triplen harmonics, so mag-a-add siya sa neutral. Then, nagre-reflect dun sa delta mo, iikot-ikot siya dun sa delta. Hindi naman lalabas yan. Yung triplen harmonics na yan, iikot lang sa delta mo. Okay, the delta primary winding provides ampere turn balance so they can flow, but they remain trapped in the delta and do not show up in the line current on the delta side. So, ibig sabihin, hindi lalabas kay Meralco. Okay? So, ito yung actual installation na experience namin na mas mataas yung neutral current versus dun sa phase current mo. Okay, ito yung controllers ng mga ilaw. Okay, as you can see, 300 amperes yung yung phase current mo, yung line 1. Pero yung neutral current mo 476. So mas mataas. So mataas yung dito, triplen harmonics. Okay, so ang solution, naglagay kami ng K13 isolation transformer. So yung transformer na yan is delta 380, okay? So Y380. Parang in-isolate mo lang. Para yung triplet harmonics mo, doon lang siya sa itong K13 isolation transformer. Iikot-ikot lang siya sa delta niya. Pero naka-design siya to cater yung mga harmonics. Okay, ano ba yung mga K-factor ng transformer? May K1, tinatawag nila standard transformer, standard lightings for motors, K1. Yung K4, ginagamit sa induction heater, SCR, AC drive, K9, mga DC drive, K13, ito yung ginamit namin, school pulse lighting, hospital, para sa mga data processing or computer, K20. So ito yung mga K-factor. K-factor rated transformer is one which is used to deal with harmonic generating loads. Harmonics generate additional heat in the transformer and cause yung mga non-K-rated transformer to overheat. Okay? Yung K-rated transformer mo are sized appropriately to handle yung additional heat and tested to UL rigid standards. Okay? So the way the K-rated transformer works uses yung mga double-sized neutral conductor or kaya yung design ng geometry design ng conductors is binabago nila. Okay, K-rating is a heat survival rating. Hindi siya treatment of associated power quality issues like voltage distortion. So K-rating daw is a heat survival rating. So yung K-factor rating is an index of the transformer's ability to supply harmonic contents in its load current while operating within the temperature limits. Yan yung mga K-factor. May 1, 4, K-factor 9, K-factor 13. So tignan mo na lang kung ano yung application mo pag nakikita kayo mga harmonics issues. So exaggerate natin yung 400 volts. Okay. Yan yung healthy na 400 volts. Okay, so pag measure mo yung line 1, line 2 yung RY 400, RB 400, yung YB 400, tapos kukuha ka ng line to neutral 230 230. Pag measure mo yung neutral mo to ground, less than 3 volts. Okay? What if naputol yung kan? Exaggerate lang natin, pero yung mangyari to, hindi siguro mangyayari pag kakaroon kayo ng basta may regular inspection kayo. What if naputol yung neutral mo connected to the transformer? So what would happen? So doon sa mga three-phase load, walang effect sa 300 sa three-phase load. Magkakaroon ka ng effect yung mga single phase mo. Okay? Pag nag-measure ka ng phase-to-phase, 400 yan, walang issue sa three-phase load. Pero pag nag-measure ka sa phase-to-neutral, magkakaroon ka ng issue dyan. So makakakuha ka ng 100 volts to 300 volts. So depending on yung loading mo. Tapos pag kinuha mo yung phase-to-ground mo, 110. Tapos pag measure mo yung neutral sa ground, bakit kaya ang taas? Mga 100 volts. So yun yung impact ng pag exaggerate natin yung 400 volts na malabo na mangyari. Okay. So again, today there is no such thing as delta-delta or y-delta. Y secondary is not only the predominant choice, but because it is the standard itself. Pagkausap mong Meralco, lagi nilang sinasabi sa'yo na dapat Y yung secondary mo. Delta Y yung bibili mo transformer. So ito yung 5 wires natin na system. May line 1, line 2, line 3, tapos meron kang neutral, tapos meron kang equipment grounding. Tapos, yan, naka-isolate yung down conductor natin for the grounding of the Y system. Tapos yung delta Y natin na galing, yung system ni Meralco, yung neutral niya, pumasok sa medium voltage switchgear natin, yan pwede ka rin mag-down conductor dyan. Huwag mo lang pagsamahin yung neutral ni Meralco sa neutral mo. Okay? So ground return method. Okay. Ito na yung protection na, ito na yung grounding system natin for the 400 volts. So, have you ever observed sa facilities nyo kung nasaan yung ground, yung banding ng neutral mo sa equipment grounding mo? So, saan nag-band? Of course, hindi pare-pareho kung saan nag-connect yung banding, di ba? So, yung mga electrical designers kasi have different strategies or method of doing this. Yung iba, binaband nila sa low voltage switchgear. Yung iba, na designer, ang banding dun sa transformer. Okay? So in our case, yung sa iba-ibang diskarte ng mga electrical designer, our inspector have a difficulty of doing yung audit saka yung inspection, yung mga testing and commissioning because of the different art of grounding and banding ng mga electrical designers. So what we did, we sat down with our electrical designers and substation panel builders to come up with a standard connection. And we like our discussion with Pujihaya. Okay, so let us discuss this one by one. So as you would observe on this slide, yung banding of the system, yung neutral mo, okay, is nakaband sa transformer side. Okay, so between neutral and yung equipment grounding mo, may CT doon. Ito yung tinatawag nilang ground return method. So how does it works? Okay, ayan, kung paano mag-work itong ground return method. Okay. Example, nagkaroon tayo ng fault dun sa line 1, yung R mo. Okay? So, since nagkaroon ka ng fault dyan, yung pan mo, yung circuit, supply mo, yung current mo is from yung line 1, yan na yung arrow. Nakikita yung arrow? Yan. So, magpo-flow siya dun sa my fault. Then, dadaan sa frame. Then, dadaan dun sa pan mo, equipment grounding mo. Babalik sa source. Okay? Since nakaband yung neutral mo to ground, makikita ng CT. Okay? Yung fault na yan. So, yung CT na yan, magbibigay ng command ngayon dun sa ground fault relay mo to trip yung breaker dahil nakita niya may line to ground fault ka. Okay? Yan. The CT that can see the ground return current. Okay. So, yan yung ground return method. Okay, ito naman yung zero sequence method. Okay. So, yung zero sequence method, meron ka lang CT na pwede mong i-install dun sa 4 na wire mo. Malaking CT para ma-cover niya yung line 1, line 2, line 3, and neutral. So, with this, yung unbalance yung titingnan niya, yung sa trip relay mo, kung may earth leakage ka, makikita niya na nag-unbalance yung system mo. So, siya na yung magko-command dun sa ground fault relay mo to trip the breaker. Okay. Yan yung zero sequence CT. Yan. Okay. So ito naman yung residual sensing method. Mas madalas ito yung ginagamit natin, yung residual sensing method. Okay. So paano ito nagwo-work? Okay. Yung presentation pala nito, yan, yung delta Y, yung transformer side mo, meron kang low voltage switchgear, then meron kang main distribution panel. Okay, yan yung mga representation ng yung equipment grounding mo, neutral grounding. Okay, so tingnan natin kung paano nag-work yung residual sensing method. Nagkaroon ka ng fault dun sa line 1 or yung R mo. Okay, so yung mo ngayon, yung source mo ngayon, okay, yung source mo sa supply, yan, yung IR, magpo-flow, yung line 1 current mo, magpo-flow ngayon dun sa fault, sa frame, pupunta sa equipment grounding mo. Yan, babalik sa source, babalik sa transformer. Okay? Yan yung kanya. So the fault current will return along the ground path, hindi dadaan sa neutral. Okay? And the sensor will have an unbalanced magnetic flux condition, and a sensor output will be generated to actuate yung ground fault relay. Kasi naka 4-pole ka naman dito. Okay? So ito yung representation niya. Yung I ground fault is equal to yung IR mo, yung line 1, line 2, IS, line 3, yung IT, plus neutral. Okay? So since may fault ka dun sa IR, so yung IS mo is 0 ampere, IT is 0 ampere. Okay? Okay, so IN, 0 din. Kasi walang dumaan na eh. Hindi dumaan dun yung current mo sa neutral. Dumaan siya sa equipment ground mo, equipment grounding system. So IN is 0. Since the return path will return along the ground path and will not sense by the CT of the ACB at the neutral, which is the proper connection to gain the fault reading. Okay? So IG mo, kung yun ang formula mo, so IG, yung I ground fault mo is equal to IR. Okay? Yan. Okay? So, ito naman, ito naman yung situation wherein nakaband ka sa transformer, nakaband ka pa sa low voltage switchgear, yung neutral to equipment. So, dalawa yung banding mo. Ano mangyayari pag ganito yung pan mo, yung installation? Okay, so check natin kung ano mangyayari kung ganito yung installation. May fault ka. Okay. So, yung pan mo ngayon, yung flow mo of the fault current, pupunta sa IR, yung fault mo, babalik sa equipment ground. Since nakaban ka sa low voltage switchgear, shortcut siya doon sa neutral. So yan, yung dumaan siya sa neutral ng pan mo, 4-pole mo. Hindi dumaan doon sa equipment grounding. Okay, yan. So ano mangyayari dyan? So balik tayo sa formula. I ground fault is equal to yung IR, IS, IT sa neutral. So since may fault ka sa IR, yung IS mo sa IT 0. Okay. Since the return path will return along the ground path that passes the neutral CT, sensor of ACB, the value of IN is equal to minus IR. Pabalik siya, di ba? IR, yung IN mo ngayon is negative IR siya. Kasi yung IR mo, doon dumaan sa mo, sa neutral mo. Okay. So since yung IN mo is minus IR, yan yung formula mo. I ground fault is 0. Wala siyang makikitang wala siyang makikitang fault with this connection. So hindi magti-trip yung breaker mo. Okay? Okay. So what if nag-ban tayo sa low voltage switchgear? So hindi ka nag-ban sa sa transformer side. Nag-ban tayo dito sa low voltage switchgear. Ano mangyayari? Okay? So let's check what would happen. Okay, may fault ka. So yung fault current mo, magpo-flow, dadaan sa equipment grounding mo. Okay. Since naka-ban ka sa low voltage switchgear, dadaan sa neutral, babalik sa source. Okay, yan ang mangyayari. So again, wala siyang makikitang fault. Di ba? Okay. So yan. So better. So sa amin ang ginawa namin is standard na with the common agreement of our electrical designer and mga fabricators. So doon na kami magbaban doon sa power transformer. Okay. So paano kung yung mga air circuit breaker mo is pre-fall, 400 volt system ka. Okay. Anyway, yung paggamit naman ng purple is usually sa mga main lang natin ginagamit sa main, dun sa tie mo. For the rest, yung mga feeder ACB mo, mga triple na lang naman yan. Okay, so yan, isang solution. Pwede kang maglagay ng external neutral city para makita mo yung makita ng system mo kung neutral ba talaga yon, current or fault current, ng ground fault current. Okay, so ito yung single line diagram ng 400 volt system. So with this presentation, meron tayong tatlong 2.5 na 34.5 kV primary to 400 volt secondary. Tapos may generator tayo na tatlong 2,500 kVA. Tapos may ATS per bank. Tapos may tie. Okay. Okay, yung mga triple mo dito sa yung triple mo dito, ang naka-purple kasi dito sa taas yung mga ATS. Yung triple mo dito sa feeder, lagyan mo lang ng kanyan ng neutral current transformer. So, anong purpose? Yung neutral current transformer is additionally applied for triple circuit breaker when it is connected to 400 volt system. Para yung triple circuit breaker can protect the ground fault. The triple circuit breaker can protect the ground fault. However, we cannot classify yung unbalanced load and ground fault. So yan, pwede naman wala kang neutral city, pero yun lang, yung hindi mo maka-classify yung unbalanced load sa ground fault. Pag magti-trip kahit unbalanced. Kasi yun wala kang neutral city. Okay, so that's all with my presentation. Okay, balik ko na sa iyo, Yasmin. Thank you.
Okay, hello, can you hear me, Mamika? Okay, so that concludes the presentation of Engineer Charles Singson. We will be having our Q&A session this afternoon together with our three speakers. So if you have questions related to the topics, you may type it in the Q&A section found at the lower part of your screen. Once again, thank you very much, Sir Charles, for sharing your time with us. Now for the awarding of the Certificate of Appreciation, may we call on once again one of our members from the TCPDC, Engineer Max Adarlo.
Institute of Integrated Electrical Engineers of the Philippines, Incorporated, Accredited Professional Organization Certificate Number IAPO-016, PRC Accredited CPD Provider Number OEE-2020-007. This certificate of appreciation is presented to Engineer Charles L. Singson for imparting his knowledge and expertise as resource speaker on the topic Effective Grounding on 400 System via Zoom, given this 12th day of June 2021, signed by Engineer Joseph Darren Claire S. Sulicar, Chairman of the IIEE Training Continuing Professional Development Committee, and signed by Engineer Alan Anthony P. Alvarez, 2021 IIEE National President. Thank you once again, Engineer Singson, and any few words for the acceptance.
Yeah, it's my pleasure, Max. Thank you very much for inviting me as a resource speaker. Gustong-gusto ko rin, tulad ni Engineer JC Santos, na gustong-gusto namin impart talaga yung namin. Yung mga knowledge namin towards yung pagtatrabaho namin ng so many years. Mahirap pag tinatago lang namin yung mga learnings. So thank you again, Max and Yasmin, and thank you to all our participants today.
Okay, sir, before we proceed, may you please take a pose muna, sir, so we can have your picture of receiving your certificate of appreciation, sir. Ayan, so smile po muna kayo, Sir Charles. Okay, so there you have it. To our delegates, we will resume with our program at exactly 1 p.m. this afternoon. We still have one more interesting topic from Sir Conrado Benondo. So for now, you may take your lunch and see you at exactly 1 p.m. Thank you very much, Sir Charles.
Thank you, Yasmin. Thank you, Max. Thank you, guys.
Thank you, First Class Charles.
Sir, thank you.
Okay,
Sir
so Sir
Alan.
Alan is here with us pala po.
Busy Sir Alan, kaya di na kami
Yes,
nakikita.
we have 3 activities ngayon po na minomonitor ng ating mga national officers po.
Oo, tama. Congrats nga.
Thank you, Sir.
Yeah. Ang ganda nung lecture mo, pang klase.
Sir Lyndon, long time no see.
Oo nga eh, namimiss ko na yung SMX sa baba.
Di bale, lang, na-vaccine na tayo lahat, pwede na yan.
Oo, pagka meron na lahat, balik sa dati. Thank you.
Nakakamiss din yung magkita-kita talaga.
Oo nga.
Mas stressful yung virtual.
Mas mahirap pag nasa bahay, kasi isang katutak na meeting.
Tama, oo.
Yep.
Sige.
Congrats, Charles, ha? Ang ganda ng topic mo.
Oo nga eh. Galing.
Thank you. Wala, kulang yung time. So, siguro mag-prepare kami ibang topic ulit para tuloy-tuloy.
Sige, lunch muna tayo.
Okay, Sam.
Sige. Thank you. Bye-bye. Safe.
Wow.